and welcome to today's session of the African Computational Linguistics Summer School. It's a pleasure to introduce Jacob Rowan, a master's student in computational linguistics at Stony Brook University. Jacob brings a strong interdisciplinary background to this summer school. He holds a bachelor's degree in linguistics and computer science from the University of California, Santa Cruz. With a deep passion for formal systems, from syntax to code, Jacob combines real-world experience as a software developer with a rich academic teaching career. He has worked as an instructor and academic director where he taught both students and educators about mathematics, computer science, and effective communication. Today, Jacob will be guiding us through Introduction to Python for Linguists, where he will help bridge the gap between linguistic theory and practical programming. Please join me all in giving a warm welcome to Jacob Rowan. You're welcome, sir.
Thank you very much. Is my audio coming in good? Everything all good?
Yeah,
Fantastic.
it's good.
Right, there's still a bunch of people trying to get in. I've been admitting everyone. If one of the other hosts here could help me admitting people while I switch to...
Yeah, we'll do that.
Yes, it will be taken
Fantastic.
care
Thank
of.
you so much.
Thank you.
All right. So, hi, everyone. Thank you for the lovely introduction. I'm Jacob. And the place I wanted to start all of this is what my goal is for all of you. So, as was said, I have a degree in computer science. I was a professional software developer for a couple years. The goal of the following sessions is not that you end up being lifelong brilliant programmers who go on to, make the cutting edge software of tomorrow or anything like that. Let me pin my video. There we go. Might be a little easier. The goal of this class and the future meetings of it over the next couple weeks is to give you the ability to be able to read some code in Python that does something that you might need, to be able to write basic scripts on your own, and to be able to look up and learn on your own how you would advance your skills wherever you really need them as a linguist. And so with that said, I want to start with explaining that my Python skills have been enormously useful for my ability to do linguistic analysis. One of the things I find myself doing all the time is what is for me a very basic task, because I've been programming for a long time, of taking something like a corpus or even just a dictionary and finding properties of the text in that corpus or in that dictionary that I need for my own research. So recently, I was working on something, and just to to test an experiment, I wanted to find every word in English that had a pattern of consonant, consonant, vowel, consonant, consonant. Now, if I had to do that by hand, reading through an entire dictionary, that would have taken me ages. But with my Python skills, I was able to get that done in 15, 20 minutes. All I needed to do was find the right dictionary, make sure I put into my Python program, what I thought all the possible consonants would be and what I thought the possible vowels would be. and have that Python program run over the dictionary, and it gave me the results immediately. All of you could be able to do that in just a couple weeks of really working at it. But the really important thing with programming is learning a programming language is in many ways like learning a natural language. There are some things that it's really useful to be taught, but the primary way to learn is by actually going and speaking. And the primary way to learn programming is to actually try some programming. So today, I'm just going to give you, in this next 2 hours here, I'm just going to give you enough to get started, so that you can start actually gaining the skill of writing your own code, running your own scripts, and iterating on your own knowledge. In much the same way that speaking to another person in a language you want to learn is the way that you learn how to speak the language that you're trying to speak. Writing code at the computer and having the computer do whatever it does is the way that you actually learn how to program. So with that said, the place you really need to get started is, and this might be somewhat basic for some of you, depending on what background you have, but what are we talking about when we say running a program? And so for that, I am now going to share my screen here. There is no substitute for actually trying it out. So I prepared a little program here. What I have here, for those of you who, are less savvy with, traditional computer software, I suppose. This is called a terminal. Every computer has one of these, although different operating systems have it in different ways. I'm right now running a distribution of Linux, and so my terminal looks like this. But if you have a Mac, there's a program called Terminal. If you are running on a Windows computer, then Windows actually comes with a few different terminals, one of them being PowerShell. That's the one I'd recommend using for this if you don't want to. There's also Linux subsystem for Windows, but that gets fancier. But this basic tool is actually the hub of how a computer runs. All the things that you're used to using on a computer are based on this. And if you were to go back a few decades, this was all we had. The way you can run a program on this is by naming it. We're going to be doing Python. And so Python 3 is the name of the program, is the way I'm about to run a program. And I'm going to supply it with this example program that I made.
Can you please
This
make
is
it
what
a
it
little
looks
bit
like.
bolder?
A little bit, okay, a little bit bigger. Yeah, hold on one second. Let's see, I should be able to, nope, wrong one. Is that easier to see?
Yes, it's okay.
I'm gonna go in a little bit further just in case. That's probably a little too far. Oh, my bad. Nope. Okay. Sorry about that. So let me run that again. So this is what it looks like for a Python program to be running. I made this program in, I don't know, 40 seconds. It's a very simple one. All it does is display the text. This is an example Python program. Hit enter to continue. And if I hit enter, the program ends and I'm back to my terminal here. These are the first kinds of programs that you can make when you learn how to program in Python. And in fact, the way I made this program let me zoom in on this a little bit. Should be able to view. Nope. Hold on. Should be 1 second. Should be able to try to make it just a little bit bigger. Sorry. Go to um 1 second. This program is fighting with me a little bit here. It's not there. It's in preferences, editor. Should be. Ah, there we go. That's much better. Okay. That should be visible to everyone. So all I did, I have this file here containing my code, and this was it. That is the program that I was just running. So by the end of today, you should be able to understand everything here. All I did was save a file containing this as a Python file. You can see that's a .py here, and that is what allowed me to run it from here. To get this working, by the way, you have to install Python, which for those of you who are trying to learn about Python, the exact way to install it depends on your operating system. And so I highly recommend before tomorrow. This is a pretty standard thing to Google to get Python installed. For those of you who already have it installed, fantastic. You can see this is specifically Python 3. That's the most recent major version of Python. And that's why I have to type it in like that. Depending on how you've installed it, there are various ways to do that. Some of you who have programmed before might realize that I'm kind of doing this the old-fashioned way. There are types of software called independent developer environments that automate some of the process of writing out your code and then manually, saving it out to a file like this and then manually running it like this. Some of the big ones are like PyCharm automates a lot of that for you. But one of the other big standards is VS Code or Visual Studio. All of those are good if you already know how to use them. But if you are learning for the first time, it can be nice just to see how does this really work from the basics, from the beginning, what is really happening. And this, just writing text into a file, saving it, and running it like this, this is how programming, this is kind of the key of how it really all comes together. With that said, the program I'm using here, TextEdit, is just the one that came on this computer. If you're on a Windows computer, it comes with Notepad. If you're on a Mac, it comes with, I think it's called TextEdit. Anything that allows you to just put text on the screen and save it and anything that allows you to access a terminal is good enough. So with that said, let's make our first program from scratch. So I'm going to make a new file here. The traditional first program is called Hello World, and it looks, like this. So you'll notice I wrote the word print, and then I put these parentheses, quotation marks, then the words hello world. I'm going to save this into this folder here as hello world.py. And now, whoops, I can go here. And there it is. All it does is display the text hello world. So in some sense, programming is just that easy. You just write down what you want the computer to do, and it does it. Again, we're starting really simple here. If so far you feel like I've been saying a lot of words about not very much, that's the point. This is, you know, I don't want to lose anyone at the very start. And as someone who's taught this for a lot of years, there's actually more going on here than you might think. Oh. It's like,
sorry, can you stop writing on the board? Can you stop writing on the board? Is it Ishmael? I don't know.
should be a way to clear that.
Yeah, I'm doing that.
I haven't used the Zoom annotation features in a long time. I think I can, well. Where was I? Right. So it's really important to understand a concept that's going to come up over and over and over again throughout your time programming, the concept of what is your input and what is your output. So in the most basic process that you can do, your input to the process is writing out your code. This is a full program that I've written out. And your output is running the program. What does it actually put on your screen? As we move throughout these lessons, there are going to be more and more complicated inputs and outputs. There are going to be different kinds of inputs and outputs. A lot of the stuff pretty quickly, we're going to be working with taking input from other files rather than just writing all the code out all at once. And then having output that might be to another file to make things easier to work with. But the core concept here is something is going to come in and something is going to come out. In this case, this is my source code, and this is its output. But on a more specific level, print is something that we call a function. Its input is a string, in this case, at least. That's the, you know, as linguists, you're probably, some of you probably heard that word before, especially if you're into the more theoretical stuff. String, you know, has a long string.
You're muted.
Sorry, that was a mistake from me.
You're good now, right?
Yeah.
Can you go back to Spring, please?
Yeah, no worries. So the word string is a long history in formal systems in general, but when it comes to programming specifically, your first definition of string is the stuff that comes between quotation marks. And what these quotation marks indicate is that I am talking about this individual symbol and this individual symbol and this individual symbol and this individual symbol in this order. So this string is capital H followed by lowercase e, lowercase l, etc., right? If I were to change this, I don't know, different words, and save it, then this program, which I'm going to run the same way, will display something else. Because what print does is it takes as input some text, specifically a string, and outputs that text to the screen. For the first programs we're going to be making for a while, the way that we're going to output stuff from the program is using this print function. And something to watch out for is, in general, functions will be something that has a name like this, and then parentheses, and something going in there that they take as input. And the function itself will have some kind of output. So that said, there's no reason why we have to limit ourselves to using this function just once per program. We can have as many of these as we'd like. And they don't even have to all make sense. Whatever we put in here, each of these print statements is going to correspond to one line of output that our program had. And in general, when you learn something, some technique that you can use in programming, especially these kinds of functions, if you can do it once, you can do it 3 times. And if you can do it 3 times, you can do it 1,000 times. If I were to write 1 million print statements into this file and then run the code, then the code would output 1 million different lines of text. Computers are made to follow exactly the instructions you give them. And programming languages don't set arbitrary limits. So one of the things that's going to keep coming up over and over again is when you learn to do something once, you can probably do it as many times as you want. So with that said, it's nice to be able to just make print statements over and over again. But it's even nicer. Let's say I wanted to do this. Oops. I want to make a print statement that says that, and then another one, and then I want to make another one, and then I want to make another one, and then I want to make another one. I'm really tired of seeing all this text on the screen, and what if I want to change what one of these says? And also, sorry, what if I want to change more than just what one of these says? I want to change what all of them say. I don't want to have to edit this over and over and over again in each individual one. You know, maybe I want to make them all say hello to everyone there instead of here. So the first kind of way to store information in a program is by making what's called a variable. So instead of doing this, let's make a variable. I'm going to call it message and set it equal to hello to everyone there. Whoops. So what this does is it takes this string and stores it in this, which I called message, but I really could have called it almost anything. I could call it, you know, I could abbreviate that. I could call it, I don't know, something else entirely that has nothing to do with the program. This, or I could even give it like a single letter name like R. This is a variable which has the particular use of storing this string. So now, if I do this, and note the lack of quotation marks, and I can do this as many times as I'd like. Oops. If I run this program, this has the same effect as if I'd written out hello to everyone there 3 times. But now let's just say I want to say hello. Regardless, that variable is storing whatever information I give it. The reason it's called a variable, that, originally comes from math, but I like to say it's because a variable can also vary. You can change what it's equal to. So you'll see at the start of this program, I have R equal to hello. Here I change it to something else. And what this program outputs is, at first, it outputs hello twice, which comes from these 2 print statements. Then it outputs, now it's something else, which comes from these 2 print statements. And the key insight here, and this is really important, again, it seems simple now, but it's going to get more complicated later. The key insight is that your program is always run from top to bottom in order. You can look at a Python program as a list of instructions, kind of like a cooking recipe. The first instruction was to store the word hello into this variable R. The second instruction was to print that out. The third instruction was also to print it out again. The fourth instruction was to change R to be something else. And then the fifth instruction was to print that out again. And the sixth instruction was to print that out again. Now, I've made one variable here, but since I've done it once, I can do it as many times as I'd like. And so let's make another variable. One rule about variables, they'll always be kind of one word like this. You can separate those words with an underscore, or if you wanted to, there are a couple other symbols you could separate them with. But if I put a space here, it's not going to work. That's going to do something different. With that said, let's set this one equal to, I don't know, some words. If I just add this and run it, nothing's changed. And that's because I have stored some words into this variable, but I have not output them. The only thing that you see when you run a program is whatever you choose to output. You could have all sorts of code that does all sorts of things, and if none of it gets printed out or output in any other way, then it's not going to do anything that you can see when you actually run the program. So now let's say I do this. Now I'm printing out whatever is stored in this variable called another variable, which happens to be some words, and I'm not printing out R. So, like I said, you could make as many variables as you want. You could make as many print statements as you want. Here's an interesting question. What if I do, well, actually, let's do it like this. What if I do that? I want you all to think about that for a second. See if you can guess what this will do before I actually run it. The important thing is I said everything happens in order, and R isn't hello until here, but we're printing it out here. So what's going to happen? This is our first error. So this is what it looks like when Python gives you an error. There's nothing to be afraid of here. You're going to see this a lot. As someone who's a professional software developer, the difference between a professional software developer and someone learning for the first time is not how many errors you make when you're programming, but how often you see them. In the sense that a professional programmer sees errors way more often because they're writing more code. So it will say something like traceback, most recent call last. Don't worry about that too much. Here's the file that I was running. Here's the line where the error occurred. And it said that I had a name error. The name R is not defined, which that is in fact what I just explained a second ago. Up here, R doesn't exist yet. It's only down here that I make R and set it equal to hello. I have indeed made an error. This program essentially does the same thing as if I'd just done this. If I just do this, I'm trying to print out a variable, but there is no such variable. I could do this. This is the thing I'm allowed to do. This is printing out the letter R, right? I made a string with these quotation marks. I put R in it, and I'm printing that out. That is a perfectly legal program. It'll print out the letter R. There's a big difference between these two things. Now, just to show you, I put the error on the first line before, but there could be lots of lines before you actually get to an error. Let's say I write a program like this. Does anyone see the error I made? If I run this, this will give me a different kind of error, a syntax error. All this first part is pretty much the same. And it tells me the line that I made the mistake on. In fact, it's specifically line 3. If you look at here, yep, it's line 3. That's the last line. And here it is. It says unterminated string literal, which is very helpful. That's exactly true. String literal is what Python is referring to. Is Python referring to these strings in the quotation marks? They're called literal because they are, the string being described is exactly the literal string that you're looking at. And so let's say that should fix the error. But when I run it, it'll show me a different one. I think this is a fantastic error message. This is another syntax error. It's saying my open parenthesis was never closed. Here's a little arrow pointing to my open parenthesis. All of these other ones, right? There's okay. For those of you who are seeing the recording there, nothing.
Can you give me a minute?
Pause for a second.
Can you give me a minute?
Give you a minute? Sure.
Someone is trying to record this meeting away from this, and I have a bot that caught that, and that was why he stopped the recording. So if you try to record away from this, unfortunately, there is a soldier that is going to catch you. So don't let us drag it beyond this. Please, we said that this meeting should not be recorded outside the ones we are recording from here. And number 2 is when you come in, please mute yourself and don't use AI note takers to join. If you use AI note takers to join, Chomsky, that is the name of the bot, is going to block the person trying to join. Thank you.
Excuse me, will the recordings be available in the case someone has to take a break?
Yes. It will be available. What part and which of the content will be available is what I'm not sure. It depends on the organizers. But so we have to be present. That's what that means.
Good to go?
Sorry for the break. Yes, we're good to go, Jacob. Thank you.
Cool, no worries. Where was I? Ah, yes. So you'll notice these parentheses are matched on each side. Here, there's no parenthesis. Python cares deeply about this. Very deeply. It's part of the syntax of the language. Having a function where you have an open parenthesis and no closed parenthesis is like having a transitive verb with no object. Python doesn't handle that well at all. And it tells you precisely what the problem is. Now, just to show you, what if I did it instead of on this line, like this? This will look a little bit different. And in fact, actually, let's really make it funky. Let's do it like this. This will give us a completely different kind of error. Oh, no, actually, right. Python's smart enough to determine that's the same error. But it won't be if I do that. In fact, well, no, I like it like this. Let's run this. Now it's saying unterminated string literal here. Okay. If I do that, now it's just pointing at this and saying invalid syntax. What the heck are you doing? So these errors are here to help you. It's really useful to get used to reading them and to not be afraid of receiving them. It's when Python gives you an error, it's not Python telling you that like you've done something horribly wrong or that you've broken something. These errors are here to help you. And believe me, it is much, much better when Python gives you an error rather than your program running, but it does something that you don't understand. Those are the hardest things to work with. Whoops, earbud fell out. The hardest kinds of problems to work with are when the program runs, but it just doesn't do what you wanted it to do. Programmers have a term for this. They say that there's a difference between, ooh, this is a good time. I'm going to make a comment. There's a difference between an error, an exception, and a bug. This is really useful to think about when you're programming. An error is the kind of stuff that I was just showing you. Something that it won't even run at all. There's a problem with it where when you try to run the program, it just says no, error, like those syntax errors. An exception is something where the program will start running, but then it'll crash. So let's make one of those. So as you might expect, computers are pretty good at math. I can do something like this. Let's say 5 plus 9. If I run this, it will print out 14. And I can do, I can do more complicated. I can do 5 plus 9 minus 2 minus 1 plus 7. And all this, yeah, that looks right. Python absolutely has math built into it. And in fact, if I want to, I could make a variable and set that equal to a number. Make another variable, set that equal to another number. And importantly, I didn't put this in a string, right? I guess I should show that before I move on. If I do this, then it's just going to print out those symbols. Whoops, I put a slash. Try that again. Yeah. Now it's just going to print out these symbols. It's not going to actually do any math. Python has special handling for numbers and, you know, the kinds of operations you do with them. So that said, let's say I want to do num1, I don't know, times num2. Times is, you use the asterisk symbol like that. This is also totally fine. You can set a variable equal to a number. Works much the same way as strings. Want to do division, looks like this. So I don't know, let's do 40 divided by 8. That sounds about right. So for those of you who are mathematicians, what if I do this? Let's, you know, give ourselves a little message. So this program, it will start. It will print out what is 40 divided by 0. And then in the middle of the program, you'll get this. A 0 division error. You can't divide by 0. It's a mathematical rule. It's a programming rule too. You will get an error if you try to divide by 0. Specifically though, you will get an exception. Python calls it an error, but for our sake, we're going to call it an exception. This is something where in the middle of running your program, it will run into this and crash. The very first thing I showed you of the name error problem, that was actually also an exception. And you can see the difference. This tells you the file, right? Whereas when I had the name error, it gives you this traceback thing. That's Python telling you this was an exception encountered in the middle of running the program. So in general, exceptions are also relatively easy to figure out, but only if you run into them. As we make more complicated programs, there might be the possibility for exceptions, and you just don't even realize it. So perhaps you're running some code that will do a division, and the first time you run the code, because of the data that you ran it on, there was no division by 0, so everything works fine. But the next time you run it, something was 0, and now the program crashes. That's part of why exceptions are a little bit harder to diagnose than errors. Errors will always happen. They're very predictable, and Python can help you very well with figuring out where they are and what to do about them. Exceptions are a little bit harder to work with because they could happen at any time, and it depends on what's actually happening in the code. But bugs are the worst. Bugs happen when your code just does something that you didn't mean to do. So if I were to do this, I would be creating a bug in my code. I clearly wanted this program to actually output, well, let's make this not 0. Let's put this back to 8. It's a little clear. I clearly wanted this program to actually tell me what 40 divided by 8 is, but what I printed out was just some text. That's a bug, and fixing that, well, it could mean anything. I have to actually go back and read my code to find where the problem is. And here's one more general tip. Reading code is actually much, much harder than writing code. That sounds really weird if you haven't done a bunch of programming before, especially when the programs are this simple. You know, this is only 6 lines of code. But imagine you had something like this that was in the middle of hundreds of lines of code. Finding the spot where this particular thing happens and reading all of the stuff to get there so that you know what it was supposed to do and what it's actually doing gets very challenging, to the point that sometimes programmers who are experienced, when they see a sufficiently complicated bug, will decide to literally just start over and try writing the thing all over again rather than trying to find where the bug was. Because reading code is so much harder than writing it. For you, that means that once you start getting some basic programming skills, don't be discouraged if you look up some code that explains the answer to some kind of, some question you have, or you try to find a script that does the thing you're looking for, and you look at it and you just can't quite figure out exactly how it works. That's totally normal. That's even professional software developers have trouble just reading code and figuring out how it works. The real trick is the way you figure out how it works is by taking the code that's there and playing with it a little bit. Turn the code that's written into code that you're writing. And that will actually make it much easier to figure out what's going on. If I were to look at this program, I'm experienced enough that I would see the problem here immediately. But one of the things I might think about is, how would I do this if I were writing this code? Well, actually, you don't even really need variables for this. If I just want to know what 40 divided by 8 is, then I can just do 40 divided by 8. And by changing this into a task where I'm writing the code, I actually fix the problem. Oh, right. By the way, this thing, this is called a comment. If you put a number sign somewhere on a line, everything after it won't affect the running code. If I were to just have this here, this would give me a syntax error of some kind. Give me a name error. Yeah. That's actually, this happens to be the way that you could write some code. If I had, if I had written something like that, this, I believe, would give me a syntax error. Yeah. Invalid syntax. The thing I had written before coincidentally looks a little bit like code before you actually try to run it. Anyway, if you want to be able to write little notes for yourself, that is how you do it. You can do it on a line on its own like this, or you can put it, anything after this will be a comment. And the program that I'm using here actually has a feature that is making it look different, right? Because it knows what Python code is. There's a fancy name for that. It's called linting. So it's making this show up in yellow and this show up in blue. And this comment is showing up in gray, specifically because my text editor knows that it's not actual code that's going to run. It's just something that I'm writing for myself. If you want to create a big comment, you can do that like this. Anything that you put between 3 quotation marks like this, called a multi-line comment, unlike these single line comments. If I run this, move this away a little bit. If I run this multi-line comment did not affect the code at all, and the single line comment did not affect the code at all. If you find code on the internet, you'll see people doing this kind of stuff a lot. It's really nice to write down what you're thinking as you're programming, especially if you want to come back to code later. It can be a very useful tool. And there are a bunch of situations where you want to document your code by writing these kinds of comments in it. Okay. With all that said, I want to introduce a whole new concept. So far, we've been running programs that just, when you run them, they either run all the way through, or they stop because of some kind of error, or they don't even start because of some kind of error. But there's a different whole thing that can happen. What if you want to be able to have the user interact with the program? So let's say I want to ask something like, what is your name? And then I want to have something happen, where the user's name, let's say it's my name for now. And then it says, hello, and then the name that was just entered. So to do that, I'm going to say, something like this. And let's call this hello user.py. So if I do Python 3, hello user.py. Now, this filled it in with my name, but what if I want to make this program such that it could be used by anyone and it would say their name? That is what the input function is for. If I run this, now when I run this program, it is giving me a chance in the terminal to type something in. So, I don't know, let's say, now, instead of saying hello to just specifically someone named Jacob, it could say hello to anyone. I don't know, let's say, my name is George. It says, hello, George. And I could run this program and type in something different every time. I could say that my name is 54. It's not actually, whoops, knocked my earbuds again. It's not actually checking anything about that name, but it is allowing me to type in whatever I'd like. This is a different kind of input than the kind of input I was talking about before. So now the input to the process of running the code is this. The input to the code as it's running is what I'm typing in here. And that I get from this input function. So you'll notice the way I used it is I set a variable equal to input. That's because this function gives you back the thing that was typed in. If you want to store that, then you can store that in a variable. And that's one of the first uses for variables. After this line, username is going to be equal to whatever they typed in, and variables still work the same way. I could, if I wanted to, print it out twice, just as an arbitrary thing I could do. So the output of the input function gets a little bit confusing with the names, but the thing that this gives you back when it's done is whatever was typed in, whatever was typed in when the input function was called. So now you know about actually two different kinds of functions. The print function is one that specifically takes in a known input and puts it out to the screen. The input function is one that is specifically for getting an input from the user using your program that you as the programmer don't know in advance. By looking at this code, there's no way to know what the human using it is going to type in when it comes time for this input. And of course, one more thing. It might be nice if instead of printing this out on another line, we printed it out on the same line. There are a lot of ways you can work with print statements in Python and strings with Python, but one thing you can do, a print statement by default will put things on the next line after the print statement. So I could do something like this with a comma here. If I wanted it to look like that. Oh, I had an extra space. Got to be careful. Strings output exactly what they have. So I can get as many inputs as I'd like in the same program. Let's also get, I don't know. And I can, this is just an ordinary variable like any of the rest of them. I can get an input and then say something like, and now I have made a program that says hello to me and then asks me for my favorite language. And I'll answer my favorite programming language. It's actually not Python, it's Haskell. And it will say that Haskell sounds like a very good language. You can use as many inputs as you'd like, and the time when they will happen is specifically where they are in the code. Remember that your code is run top to bottom. And so you can put things between them. You can, let's say I want to say, I want to refer to the person by name again. Oops. Do something fancy like this. Now let's say, I don't know, I'll answer as someone else. And I'll say that my favorite language is Sanskrit. I typed in that input here. This input came next, and I'm able to print it all out like that. This is kind of your first basic usable program that actually does a task. It's not yet a very interesting task, but a task is a good start. This, by the way, down here, the way I'm using the commas in the print statement, there are actually a lot of different ways I could have done this. I could have also, strings allow you to add them together. And so I could have done this. And this would have the same exact effect. I don't know. Let's say James, and James's favorite language is Cantonese. These pluses are accomplishing the same thing as those commas from before. And if you look up code that someone else has written, there are many different ways to accomplish the task of printing a bunch of things out in the same line. And in general, throughout these lessons, some things I'm going to show you multiple ways to do them, but a lot of them, there are tons of correct options. And I'm just going to be showing one way to get things done. So I happen to prefer, oh, right. One thing about the pluses, the way the commas work is print is specifically designed that if you have like a comma here like that it will, when it comes out, it will put a space. But you'll notice with the pluses, I had to manually put a space here and here. That's because pluses are something you can do with a string in general. If I wanted to, instead of doing this, I could have done this. Oops. Made a variable and set it equal to this whole thing, and then just printed out final message. And this will, once again, do the same thing. And let's say Timothy's favorite language is Espanteco. All of this accomplishes the same goal. And in general, actually, you can mathematically prove for any program that you want to make, there are provably an infinite number of correct ways to do it. If you're a computer scientist, you might care a lot about like the specific efficiency of doing it one way versus another way. But for our sake, that's almost certainly not going to matter at all. The kinds of tasks that we're doing here are tasks where you could do them a little bit inefficiently or even very inefficiently, and computers are so fast, you'll never notice the difference, especially for stuff this simple. Okay. So now that we have kind of a basic program that allows you to do stuff, let's make things more complicated again. Oh, at this point, that example that I started with at the beginning of this class, this should now be understandable. You'll notice here, I didn't even set a variable equal to this input. What happens when I run example.py, which I haven't done since the start of this session, is it just says hit enter to continue. I could have typed anything here, but since the program ends after this input, it doesn't actually matter. I don't need to store any information from it, so I'm just getting it and letting the program end. And that's a thing you can also do if you really want to. You are now at the point where you should be able to fully understand everything that was in this example program from the start. So that said, let's introduce something new. So one of the other things that's really nice to be able to do, especially if you're going to have something that interacts with a user, is you want to be able to do different things depending on what that user says. So let's say, oops, there we go. You want to be able to say something like, you want to be able to have the user answer this question. And then only if they say yes do you actually want to tell them the answer. Well, in that case, here's a new programming construct that lets you do that. It's called an if statement. But, well, actually, before I show you that, I could just say, I hope you answered yes. This isn't a very good program. If I run this, Python 3, if statements.py. Well, if I answer yes, it works great. But if I answer no, it's not actually responding to anything that I'm typing in. So with that said, let's improve it. An if statement is made by typing if and then giving a condition that you want to check whether it's true. So I could check if the answer variable I just made is equal to yes. And if it is, then I can say my favorite language is Haskell. This program is going to work differently. When I run it, when I run this program, if I answer yes, then it'll say my favorite language is Haskell. But if I answer no, the program ends. So the way an if statement works specifically is when your code encounters an if statement, it will look at this and it will determine, is this true or is this not true? If it is true, then whatever is indented into the if statement, which in this case is this print statement, will happen. If this is not true, then whatever's indented in here will simply be skipped right over. So with that said, I could have something that happens after this if statement. Let me give this a little more space. I could have something, like, I don't know, thank you for using my program. If I run this and I say yes, then it will say my favorite language is Haskell. Thank you for using my program. If I say no, it will just say thank you for using my program, because this is not part of the if statement. This is in there. Now I could have more stuff happen in here. Maybe in here, I could then say, what's your favorite language? And then, have them input that. And say, something like that. And now if I run this, there's a whole oh, whoops. Would you look at that? I missed an end parenthesis. Like I said, this happens all the time. I didn't even do that one on purpose. That was totally natural. Ah, there we go. So now if I answer yes, it'll say my favorite language is Haskell. What's your favorite language? Let's go with Swedish. And it'll say Swedish sounds interesting. Thank you for using my program. But from the very start, if I say no, that's it. So with that said, this if statement is specifically checking if this variable answer, this equals equals here, is checking if two things are equal, and it's checking if it's equal to the string yes. So if I were to run this again, and I were to type in sure, that's not the same thing as yes. If I type in absolutely, that's not the same thing as yes. If I type in yes with a capital Y, that's not the same thing as yes with a lowercase y. Those are not the exact same string. Let's say I type in yes, but with a space after it. Still not the exact same thing. This is very specific. It is checking for whether this variable is storing an exact sequence of lowercase y, lowercase e, lowercase s, and nothing more. With that said, there are a few ways I could relax this a little bit. One of them is I could very simply do this. I'm going to copy this entire thing. And I'm just going to make another if statement after it. And this time, do that. Now, if I say yes with a capital Y, I just copied that whole functionality over. So it works the same way. But there's a much better way to do this. I can also do it like that. Python is familiar with the semantics of the term or insofar as you would mean in something like this. This works exactly the way you would expect it to. If I say yes like that, now it asks me a favorite language. Let's say this time, I don't know, Yoruba. If I still works, if I say no, still skips right over that. So crucially, by the way, I have to type out answer equals yes again, and not just a common mistake for new programmers. They'll do this. Let me show you what happens if you do this. I said no, but it's asking me these questions anyway. That's because what you've actually done here is the same as this. This will run the exact same way. And that maybe closer reveals all this or is doing is it's checking if this thing is true or this thing is true. And Python's idea of true, if you put a string here, a string is like not exactly truth as we think of it, but Python is willing to count that as being true enough. And so it will proceed down into here. This is not what you intended. And this is a classic bug. It's not an error or an exception. The program runs just fine in the sense that it will never stop me. It won't, you know, it won't say like name error or something like that. I haven't done English yet. That's a good language. The program is running, but it's not doing the thing you want. So this is a classic one to watch out for. What you really want is to check whether this is true or whether this is true. Now, these if statements are going to come up a lot. If statements are something that you're going to see very, very frequently, and you'll notice that everything we've learned so far has come up multiple times in multiple different ways. The goal today, again, was to get you started with programming. All of this stuff is crucial to doing that. I see someone has a raised hand. I don't know how much time we have for questions of that kind. So I think I'm gonna have to kind of keep on moving here. But I'll see.
Yes, you can continue.
Look at that again. Okay, where was I? Right. So, one of the things that's also really important. So, as I said before, if you can do something once, you can do it as many times as you like. If you're inside the block of an if statement, there's nothing stopping you from writing whatever code you want in here. And whatever code you want could include something like another if statement. Let's say I want to do, I'm gonna put this up here actually. And let's say I only want this to happen if the language was not equal to Haskell. A couple ways I could do that. One of them, this is the way to write not equals. I could have also said not lang is equal to Haskell. Python is totally fine with just the word not for that. Although a whole other thing I could do here is just after an if statement like this, you can have what happens otherwise. And that's else. So if the language is Haskell, this will happen. If the language is not Haskell, in any other situation, this is what will happen. And so now, if I run this, now let's say I say yes, and I say that my favorite language is Haskell. It will say, you must be a programmer. And then the program will end. Sorry, then it'll say, thank you for using my program, and the program will end. If I say yes, and then I say something like, I don't know, let's go with Mongolian. It will say Mongolian sounds interesting, and it will not say you must be a programmer. And then it will say, thank you for using my program. And just to be clear, if I say yes, and then I type some nonsense, that's also going to go into that else condition. And all of this is only happening if I even say yes in the first place. I could also just say no from the very start, and none of that will happen. Pretty quickly, as you start making programs that kind of do relevant things, there will be a bunch of different paths that your code could take depending on what the user does or what the input you've supplied to it does in some other way. And so it becomes useful to start kind of thinking of this as kind of like one big tree, not that different from a syntax tree at the end of the day. Some people like to make specifically flowcharts for this to map out all the different paths their code could take. In this case, it kind of stayed relatively simple. There's only so much going on here, but if you were writing code, even with like 50 lines, then it might be a little bit harder to see just by glancing at it exactly what all the possibilities are. But one of the things that's crucial, the way I know that this is part of the if statement that I started on line 8 is it's indented so that it's in this big if statement. And then it's indented again so that it's in this if statement. Whereas this is not indented at all. There's a big difference between this and this. And this is further in than this. Python is what programmers call white space sensitive. It cares about how many spaces you have in each place. The fact that this looks visibly inward matters. There are other programming languages that don't work like that, but Python does. So if I were to do something like that, this won't work at all. Look at me an indentation error. It expects an indented block after an if statement on line 8. And even if I were to do this, now it is indented, but not enough. There has to be an indented thing after this if statement, not just indented into this one. And by the way, you can completely break a Python program by doing something like that. Now it's all out of whack. It says there's an unindent, and it does not match any outer indentation level. There's all sorts of fun stuff you can get. So if you're having issues with your Python program, oh, right, not to mention, I could easily break this in other ways by doing something like, let's say I did, if I put this like here, I could, if I really wanted to, put the whole thing like this and start really messing with my code. Now it's saying there's an unexpected indent on line 1. If I try to fix it and I move everything back, but I move them back differently, I can end up with all sorts of different results. Like now all my code is out of line. And any number of things could happen from here. You really don't want to mess with this stuff. That's one of the nice things about working in the program that I'm working with here. It allows me to hit the tab key to realign things to where they're supposed to be. And there's a shortcut that a lot of programs have where if you select a bunch of text and hit Shift Tab, it'll move it all back. And if you hit Tab, it'll move it all out. So let's reset this. This should be here, but these should be in. And in fact, all of these should be in. And this should be one further in, and these should be one further in. It's very easy to cause yourself problems in Python by just messing around with your spacing in a way that you didn't mean to. And it can completely prevent your program from running. So there will be more things in Python, by the way, that care about how things are spaced out. Right now, we just have if statements, but there are also loops and function definitions and class definitions and all sorts of stuff. So you got to be really careful about making these kinds of mistakes. And remember that Python cares about even the tiniest little detail like that. And the worst case scenario is when it doesn't even create an error. It just creates a program that does something that you don't want it to do. So remember that if you're getting indentation errors, you should probably go back and really carefully try to fix all the spacing. because if you fix the spacing incorrectly, then who knows what your program's going to do. But okay, with that, now that we have if statements and input and printing, now we can do some, fancier stuff. So make another new file for this. Let's make a little game here. So I got muted there for a second while I wasn't saying anything anyway, so nothing lost. All right. I make a program that the user has to guess a number between 1 and 100. So let's say that number, let's say my number, let's say it's actually 34. Now I can make something where the user can input a guess, and if the user's guess is correct, it says that. If the user's guess is too high, if it's greater than 34, it'll say too high. And if the user's guess is less than 34, it'll say too low. Now, there's actually a few things wrong with this program. I'm going to tell you that right now before I run it. But some of them might be things that you could guess, and some of them might not be. So it's worth taking a second, see if you can think about it and figure out where the problems might be before I run it. Whoops, wrong program. By the way, if you're running a program in a terminal like this and you just want to end it without caring how, like you don't want to get to the end of the program, Control C is the keyboard interrupt. That will just end a program. But yeah, I wanted to run Python 3 guessing game.py. Great. So I will guess 50. I guessed 50 and I got this giant error. It says greater than, not supported between instances of str and int. Now, what does that mean? When you do an input, the computer expects that what you've put in is actually a string. It's text. That's the default of how that works. But 34 is a number. It's not text. So one way I could fix this, well, actually, before I show you that, let's just show you what happens if I get rid of this part. I'm going to give up on that part of it. This is called commenting out code. Really useful thing to do when you're trying to figure out a problem. Now, this part of it, because it's a comment, won't run at all. Let's try this again. Okay, it didn't say that's correct, but that's what we'd expect. I put in 50, and that's all this code does right now. It checks if it's correct, and if it's not correct, it does nothing. Cool. But now if I do 34, it still doesn't think I'm correct, even though that's the number that I said I was going to enter, right? The thing entered as inputs, because it is a string, will not match a number unless I do something like that. I actually said I was going to do that up before. I could do this. And now if I type in 50, it'll still do nothing. And if I type in 34, now it'll say that's correct. But that's not really the way I wanted to do this, because that's not going to work with this stuff. I don't want to check if it's greater or less than the string 34. I actually want it to be a number. I want this to be a number. So what I need to do is take this input and tell Python that I actually want to treat it as a number. And the way to do that is by doing this. So this is another function, int, int, short for integer. It says, whatever you give me, turn that into an integer number. And this is specifically what we're looking for. Now, if I do 50, still do the same. And if I do 34, it'll say that's correct. And if I bring this stuff back, now if I do 50, it'll correctly say too high. If I do 12, it'll say too low. One of the things about the way Python works is every single type of data, well, I already said it, every single piece of data has a type. There's a difference between this integer type and this string type. And as you work more with Python, you might see even more different types. In fact, you're very likely to, depending on what you do. These types matter. Two things of different types are never going to be equal. You have to make sure that you're working with things of the same type to be able to actually work with them the way you expect. So with that said, I could now play this game by continually running this program. Whoops, that's not the one I wanted. There we go. All right, I can put in like 60 and, oh, sorry. That's because I hit the slash key right when I was trying to start the game. There you go. And it would tell me too high, and then, you know, maybe I could guess 30, and that would be too low, and then I could guess 34, and that would be correct. But I could actually make this better in a few ways. So, first of all, there is a nice little feature, elif. This will make it so that it won't even check this condition or this condition if this one was true. And specifically, this will make it go, Python will work like this when you have elif. This is short for else if. It will check this first, and if it's true, it'll do this, and then it'll skip past all the elifs. It won't even check them. Which is good, because if the user guess was the number, then it's not going to be greater than 34 or less than 34. This is also a nice way to signify to someone who's trying to read your code how this is supposed to work. The idea here is, out of these three things, only one of them is going to happen. And once we have an elif like that, we can also have this one just be an else. Now, it'll still only do one of these, but we already know if it wasn't equal and it wasn't too high, there's only three things that can be true, right? numbers can either be, well, integers can either be equal to each other, one of them can be bigger than the other, or the only other option is that it was too low. We can start making our code a little simpler in this way. The other thing we can do is, if I change this to my number, then it becomes easy to change what the number is if I want to change the game. Now, if I say 50, it's too low. And if I say 90, it's, whoops. If I say 90, it's too high. And 79. Not if I just type it into the terminal. And if I say 79, that's correct. But even better, let's say I want this to be a random number. This is the first time we're going to import something. This is something that's going to come up a lot. Specifically, from random, we're going to import, whoops, that's not the keys I wanted to hit, import randint. Let's see if I remembered that correctly off the top of my head. Yeah. What this will do, randint, let's take this one step at a time. Randint is a function that generates a random integer. It's not part of Python by default, in the sense that if I had just written this without this line of code, which I'll show you by doing this, Python would have said, what is randint? Name randint is not defined. It's something in what's called a library, and as you're doing more sophisticated stuff, libraries are going to come up frequently. A lot of useful stuff has already been made. From the library called random, I'm bringing in randint so that I can use it in my program. That's what this first line does. And in general, it's a good idea to put all your import statements, which there could be multiple of them or many of them, right up at the top of your program. Now, when I do this, it's going to generate a random number, and let's actually make this possible. There's no way I'm going to guess a random number from 1 to 100. Let's say it's a random number from 1 to 5. Whoops. Let's interrupt that. I forgot to update this. This, by the way, comma separated thing is the range that the random number is going to be in. Being able to make random numbers like this isn't necessarily super important. The point of this lesson isn't to teach you specifically how to make random numbers. I don't know, it could be useful for some things, but the important part is really this part. This is the thing that's going to come up later. There's going to be a lot more stuff to import. And also it's important to see another function where you give it inputs that tell you how you want it, that tell the function how you want it to work. And it gives you back an output, in this case, a random number. But anyway, now let's try 3. Hey, I got it first try. If I do 3 again, that time it was too high. If I do 3 again, that time it was too low. It's randomly generating a number. So I could try 2, that was too low. I could try 4, that time it was too high. Let's keep going until it is 4. And that's a basic little user interactive program that uses if, elif, else, random numbers. You have just learned a lot in the last hour and 40 minutes or so. Just with the tools that we talked about today, you could actually make some surprisingly interesting programs. So all of this stuff is kind of like the absolute core of how every Python script is going to work. You're going to perhaps import some stuff. You're going to print out information. You're going to use functions that you imported and store information in variables. You're going to get data of the type that you need it to be, perhaps straight from a user typing something in. And then you're going to determine things about that data and tell the user what you determined. That is a basic script. So if we wanted to, we could pretty easily give the user more guesses with the same number just by doing this. Although perhaps we don't want to do this if the user got it right the first time. Let's move this up a little bit. There we go. So this is now 2 guesses, right? Oops. That earbud keeps falling out. Okay, there we go. So now I could do like 2. That's too high, so I guess it's 1. Problem with this being, oops, too low, so it's got to be 5. What happens if I get it right the first time? Oh, yeah, right. That's another whole thing that can happen. If I say that this is going to be an integer, and then what I actually do as a user is I type in something that's not an integer, I'll get a value error that the thing I typed in was invalid as an integer. Just so you know. But I just want to show you. This could happen where I get it right on the first time. I'm getting really unlucky here. Here, wait. Let's change this to be Geez. If I get it right on the first time, it's still going to make me guess again, which is probably not what I want. All of this should probably actually be in one big else. Okay. Now, if I get it right the first time, it'll just end. And with that, I think that's a good place to start wrapping up for the day. I am going to be teaching more Python for Linguists tomorrow. Tomorrow we're going to get into some of the more interesting stuff like loops and the basics of functions so that we can start getting to reading and writing stuff from files and all the basics of that. So with that said, as I said at the beginning, the best way to get better at programming is by actually writing code, right? So before next time, I recommend trying to find some way to be able to actually write code on your own machine. ideally, something that looks like this, if you know, you can just Google like install Python, and like all these come right up, right? So I don't know, let's just say Windows, right? And python.org will have a download for you, and this is a great way to do it. You can test if Python has been installed by just doing Python 3, and it will say this. You can exit this by doing exit. Doing this in your relevant terminal. If you look up like videos online of just people getting Python installed, there are tons of them, and they can be very straightforward. But if you're really having trouble, for now, if you just want to try some things out, there are also a bunch of websites online that say, you know, something like run Python code online. It's like online Python here is one of those. That just lets you write Python code and run it by hitting this run button here. You'll notice this is very slow because it's not actually running on my machine. But whatever it takes for you to be able to find a way to run Python code, an exercise I'd recommend trying before next time is, here. There we go. An exercise that's good to try before next time. Try making a program that similar to the programs you were doing here. Try making a program that gives the user a little bit of a quiz. So maybe it asks the user a trivia question, and maybe with a follow-up, only if they get the first right. And maybe gives a hint if they give an answer that's close to the right answer. Whatever that means to you. Make a program, you know, ideally by tomorrow, get something in Python running and see if you can make a program that does this, so that using the program, it would look like, you know, it would ask the user a question like, here's a very basic question you could ask, although it's more fun if you do more interesting ones, like what is 5 plus 10? And then let's say, you know, the user answers 15, then it would say that's correct and the program should end. But if the user answers, I don't know, 14, it could say that's close. Maybe give them another chance to answer. But if they answer something like fish, then it can just say something like, that's incorrect. And if you can make a program that works like this, you know, change out this question for something more interesting. I don't know. What is the capital of, let's say, Brazil? That's a more interesting question than the question I asked before. If they answer fish, that's incorrect. If you can make a program that does that, then you've learned all of the most relevant lessons from today. And you're ready to get started with what we get started with tomorrow. So with that, I think we're coming up to the end of the time we have here. Hola, you have your hand raised?
No, I didn't raise my hand actually. I just wanted to thank you for the section. It was really interesting. And I would say this is like the simplest Python tutorial I've ever been. The times I learned, Python wasn't this gentle. It was really fast, and it was not really linguistic in that sense. Just a little quick announcement before I hand up to the session assistant instructors. We'll be meeting this same period tomorrow. It's gonna be 12 to 2 p.m. New York time. It's gonna be 5 to 7 p.m. West African time. Whatever, I don't know how to calculate others, but I'm conversant with these hours. So you should be around. So we would try to put this video on our YouTube channel so that people can follow up and keep practicing as they watch the videos. More importantly, there is a forum on the website. If you go to linguisticsIreland.com, there is a forum there. So if you registered, you can use the forum. The forum is designed so that Jacob can look into the forum and see your questions, see your interaction, see how much you are learning. And he can answer, he might not answer, he might see how you are doing and try to make it easier for you to learn. So that way you are not only learning on Zoom here, you're also learning at your comfort. So you can try to do something on Python and you have some issues, you can post your answers, your questions there. I'm sure Jacob will be checking the forum. I will be checking, everybody here will be checking the forum to see your questions so that you don't repeat people's question. You can just see if they've answered this person's question. And I would say try to search for a question before you ask so that you don't repeat. Jacob does not keep answering the same question over and over again. I think that would make it easier for everyone. So just keep engaging. The best way to learn is to just open your laptop and start doing it. Make errors, make mistakes. That is the way to go. Thank you so very much. And I will hand over to the assistant instructors.
And by the way, feel free to discuss with each other, or it's like I just gave a short task to do. Feel free to post your answers and share them with other people. See if you can compare answers. There are actually a few different ways, given the talk I just gave, there are a few different correct ways you could end up doing the thing that I just said. So I highly recommend, if any of you know any of the rest of you, I know I'm talking to like 100 people, but if any of you know any of the rest of you, feel free to work together. It's a fantastic way to learn. But that forum is the place where you can all work together and post answers, post questions. I will definitely be checking that at least every few hours, especially between today and tomorrow. And after tomorrow, I'll be in the same way that I like put up a task for the end of today. I will be uploading at the end of tomorrow's, like at the end of the talking that I'm doing tomorrow. I'll also talk about some of the stuff that you should try doing, but I'll also be uploading some practice tasks that you can do that have like more detail and example answers. Those are for your benefit. Like I said, the best way to learn is by getting in there and trying it. So I'll be using that forum. Please, if you see someone else has a good question, but you don't know the answer to it, make note that you think that's a good question. That's your question too. I'm going to be trying to answer the most popular questions in that sense, but I'll try to get to everything I can. But really, you are each other's best resource in the sense that I already know all this stuff. So, some of this, it can be easy for me to forget that, like, I didn't say something very important. You're all great help to each other in you're all on the same page about and which things you're not. So with that said, I really highly encourage using that forum. It's a fantastic way to learn alongside, getting in some programming yourself. But with that,
yeah, thank you so very much, Jacob. Can we celebrate and appreciate Jacob for the excellent job he's done? I'm really, really over impressed I'm fortunate actually to be here and to learn. The assistant instructors, what do we do next?
Hello, thank you, our instructor, for this wonderful teaching. The pedagogy was very, 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 very friendly to the learners. Anybody who has ever made an attempt to do Python, either by watching the video or anything, will know that what you have given us here was quite learner friendly, and that we are very grateful to you for. I don't know, we would want people to use more of the forum, as Samuel has said. But if anybody has a very quick question he or she wants the instructor to talk about, just use 30 seconds to ask your question. And please, before you ask, you will have to raise your hand so that will not turn it to a chaotic situation. Secondly, as you want to ask your question, please do well to remember to mute yourself the moment you finish asking your question. And that will help. If you're in a place where we can see your face, that will be very nice to keep your video on. But if you are not comfortable with that, just go ahead and ask your question. Yes, I have 2 hands raised already. One is David. David, you can ask your question. After David, Habib will ask. So please, David, if you can hear me, unmute yourself and ask your question. You have just 30 seconds to do that. Thank you.
Question is that I want to know whether this is actually a test subject. Are we going to like present it or submit it during the next class?
Are you asking about the question he put up, the instruction he gave?
Yes, like the question that's there right now on the shared screen. Are we to like present it during the next class?
Just practice. There's a practice question. I think it's a practice question.
Yep.
You won't have time for present. Yeah. Okay, please answer, sir.
Yeah, ideally try that by next class. That's my advice to you, to make sure that you got everything, the most important stuff from the lesson I just gave. So if you can complete that by next class, then that's your sign that everything's going well.
Okay, thank you very much.
Absolutely. Right, and then there's one more question, right?
Yeah, Habib.
Hello. Can you hear me?
Yes.
Yes.
Okay. So thank you so much, the Linguistic Island and Jacob. Honestly, this class was very impressive and we learned a lot. And I have at least about the 3 questions that I have for Jacob, please. Very quick. One is, does it necessary to start coding with print, for example, write print? Sorry if the question is very basic. So
To start coding with, say that one more time.
yes, I said, does it necessary to start coding with writing, print, quotation mark, or something like that? Yes.
So the first program I showed was the print and then the quotation marks and all that. So that's a great, like, you can, I'm still sharing my screen, right? Of course, you can have a program that starts with something else, but I highly recommend for your very first program, doing, I had it open here somewhere, this Hello World program. Right, I changed it, but let's just put it back to print Hello World. Because the last thing you'd want is to try writing a bunch of complicated code, and then you don't even know if it's working or not. So I would highly recommend starting by just writing this, making sure everything's working, and you can test if it works very easily by doing Python 3 on my machine. It could be just Python on your machine. For some, like if you're on Windows, it might be Python 3.exe or Python.exe. Depends on how exactly you end up installing it. But this was Hello World. Oh, I forgot to save it. That's the most important part. And just making sure that this matches this. And I highly recommend starting there. Then you can try, more complicated exercises where you try to figure out how to solve like the exercise I gave just before.
Okay.
Did I answer your
Thank
question?
you so much, Mr. Decker. Yes, of course. Thank you so much.
Of course. Okay, I think that's all the
Yeah.
time
That's all
we've
the
got
time.
here.
Thank you
I'm
so
gonna
very
stop
much.
sharing.
Yeah, that was very impressive. Impressive. And so yeah, we'll be meeting tomorrow, the same time, the same venue. I don't know what to do about the people that can't access the forum. I don't know the specific error you are getting or the specific issue you have. If you log in, you should be able to you should be able to access the forum. But if you didn't log in, you won't be able to access the forum. So why we kept it like that is so that anybody from anywhere would not just ask any question that has never been covered in the class randomly. And when I mean login, I mean like you must have registered for the summer school. So yeah, I hope that answered many questions. As I said earlier on, our videos will be posted in on the YouTube channel so that everybody can see from anywhere and you don't have to keep sending it out to people differently. Yeah, I think someone, Evelyn Isioma, has a question.
Okay, good evening and thank you very much for the lecture. Please, I couldn't I just registered from the registration, but I cannot access anything. I actually started registering with one email and then another, and it wasn't just going. And then just the last day, a third email, which I don't usually use, is my school email. And so that was, and I've been waiting. I was told they are going to send an email to let me create my own account, but I've not been able to. So I tried to log in and it will not allow me.
Well, I think if you have used the wrong emails, then it won't work. I mean, if you are using different emails.
It's a correct.
So
it's a correct email.
Okay, if you didn't use the same email that you used to register to,
I got one message on that email that another they are going to send another email on how I will create, but I'm trying to use that one, but it's not going.
You are trying to use the email that you have used to register to join the meeting, but it's not going. I don't understand. Yes.
To enter from the website. So it's just the email that I
yeah, so if you have, I think we'll troubleshoot this later. I don't really want to take much of people's time. I don't even know what to do. I don't know what to do now. I'm trying to say that if you use an email to register for the summer school and you have an account, it is that same email you will log in. When you log in, then you will go to the forum. If you are using a different email that you have used to register to log into the account, it won't go. And I said that we've done that so that we can prevent any how question, so that the question will be based on what Jacob has taught, for example, and every answer assignment is given. You can post them there. Nobody is going to, in a sense, go back to every answer because we have a very large class. Go to everybody's script to keep giving them answers. So the forum is just how or the best way we can help people to learn better. I don't know if that answers your question.
It's okay, don't worry.
What did you say?
I said it's okay.
Okay.
But I'm having problem logging in, but it's okay because I have.
You're having problem. You didn't create the account. Is that the issue?
Yes.
Okay. I thought you said you created the account with an email.
No,
and you're using
no,
another
no,
email to join the one.
No, I didn't create. I cannot create the account.
Yes, you can't create the account because the registration is closed. I see the question. I think what I can do is to put a button there. Then there's no point having people register, right? Because the issue is that if we open it up for people from anywhere to comment without registering, then we have defied the fact that people were meant to register at a particular period of time. So I'm afraid.
Registered, though.
You-
I registered.
Did you register? Then your email has created an account. Maybe you don't have a password, right? You didn't reset your password. If you didn't reset your password, it's a different thing. And I can send you a link that you can use to reset your password, if that would help.
Okay, thank you.
Or you can just say forgot password. Once you put the email,
okay.
and just put forgot password. Yeah, somebody wants to say something.
Yes, I think I had the same experience. What I did was I just clicked forgot password and I got my password reset. I think that's what you can also do, like someone suggested.
Okay.
If you have registered
All right.
before.
Thank you. Yes, I registered. Thank you.
All right, thank you. Yeah. So yeah, I mean, on this, I would hand this over to the class instructors to finish up the class.
All right.
Thank you.
Do we still have someone with questions?
Well, we are
Sorry,
both,
I got kicked out. My system shut down suddenly with little warning. I wasn't paying attention to the battery until the thing went off. So
Who said
I think
something?
we're done. We're past our time.
Yes, yes, we are.
Taking
Yeah, we
questions
are
now.
past. Yes, we are past our time.
Thank you very much.
all right,
for
thank
attending.
you.
Thank you.
Thank you. Have a great weekend.
You too.
Thank you.
Thank you.
I really appreciate the session.
Thank you.
Thank you.
Hello. I think recording should have stopped long ago.
Yeah.
It's recording. To make it neater,